Yes, sir. Okay, fine. Yeah, please start.
Yes, sir. Sivaraman sir,
Thank you,
welcome.
sir.
Yeah,
Welcome, sir.
very good evening, madam.
Good evening, sir. Good evening.
A warm welcome to all gathered here. On behalf of IEEE Madras Section, IEEE Madras Section Young Professionals Affinity Group, and IEEE Madras Vehicular Technology Society, it's indeed our great privilege to welcome you all for this technical talk on electrical vehicle charging infrastructure, which is delivered by Engineer Shivaraman, senior member of IEEE Power Energy Young Professionals and IE Subcommittee. I welcome you all for this wonderful occasion. On this occasion, I extend my sincere thanks to our Vehicular Technology Society Chapter Chair, Dr. Brinda Swaminathan ma'am, and I also extend my sincere thanks to our committee, EXICAM committee members who have joined. Welcome, Nagaraj sir. I also extend my sincere thanks to all the participants who have joined here for this session. Before moving on to the session, it's indeed my great privilege to introduce today's speaker, Mr. P. Shivaraman. Was born in Madurai, and he has completed his schooling in Government Higher Secondary School, Vellalur, and B in Electrical and Electronics Engineering, ME in Power System Engineering from Anna University, Chennai in 2012 and 14 respectively. He has more than 9 years of industrial experience in the field of power studies, power quality studies, and harmonic assessments, troubleshooting for various power quality problems, EV charging infrastructures. He has trained more than 500 personnel on renewable energy and power quality. He is an expert in power system simulation softwares like ETAP, Resilient Power Factory, and PSSE. He is an active participant in the IEEE Standard Association. He had authored and co-authored, edited 8 books in the field of electrical engineering with Elsevier and John Wiley, IEEE Press, published several papers in national and international conferences. He is a senior member of IEEE and also a member of IEEE Power Energy Society Young Professional IE Subcommittee. He has received several awards, which also includes professional engineering certifications from IEEE, and also speaker of well-known several forums. He has talked both national and international in standards. With his huge profile, it's indeed our great privilege to welcome you, sir.
Thank you, sir, your brief introduction. I will directly share my screen and go to the presentation. Let me know once my screen is visible to you all. Whether can anyone confirm whether my screen is visible?
Yes, sir. Screen is
Yes,
visible,
sir.
sir,
Yes,
and
sir.
we are ready to go, sir.
Yeah,
Screen is
thank
visible.
you. Thanks for your confirmation. Yeah, I once again welcoming you all. Can you turn off your mic, ma'am? Brinda, ma'am, can you turn off your mic? Yeah, good. Thank you. I'm once again welcoming you all to this webinar, EV charging infrastructure by IEEE Madras section. Yeah. So myself, Sivaraman, I'm one of the senior member of IEEE and the member of IEEE PSYP IND subcommittee. So in this presentation, I will take you through the basics of EV and the Ministry of Power guidelines for the EV charging infrastructure and some exciting photos about the EV charger, EV charging, etc. So I will skip this self introduction and moving further. Yeah, this is the book written by me, the fast charging infrastructure for electric and hybrid electric vehicle, along with my professor Sarmila and Sanjeev Kumar. It is published by Wiley and IEEE Press. It published in July 2023. So some of the aspects in these presentations are taken from this book. The credits goes to all the authors of this book. So these are all some of the other books written by me. So I will directly move to the presentation. Before starting with uh, the charging infrastructure. I will give some light about the needs of the EV. So as we know, the conventional petrol and diesel based vehicles are having some constraint, especially the environmental pollution, and second one is the higher cost of petrol and diesel. So in simple words, the day by day, the cost of petrol and diesel prices are increasing. So these are all the some of the constraints which driving the electric vehicle. So the electric vehicles, they are cleaner in nature, so it will not pollute the environmental. So in simple words, it is free from environmental pollution as well as preserve the fossil fuels. And about the other advantage is that the maintenance and operation cost. So compared to this petrol and diesel based conventional vehicle, the electric vehicles are required less operation cost as well as the maintenance cost. So these are all some of the factors which which drives the electric vehicles as an alternative to the conventional electric vehicle. So about the type of the electric vehicle, in a broader perspective, we can classify the electric vehicle into two types. One is the plug-in electric vehicle and another one is the hybrid electric vehicle. So plug-in electric vehicles are battery operated electric vehicles, be in simple form, BEV, battery operated electric vehicles. The hybrid electric vehicles, it's a combination of two resources. One is the battery and another one can be an IC engine or fuel cell. So these are all the types of electric vehicle in a broader perspective. About the electric vehicle, based on the application, we can classify this electrical vehicle into the following categories: electric two-wheeler for private vehicles, then electric three-wheeler for commercial vehicle. So in this one, we can say uh, electric three-wheeler for goods carrying purpose. That is one type, or electric auto, that also comes under this category. Then electric four-wheeler for private vehicles. So it is for our own use. Then next one is the electric four-wheeler for commercial vehicle. So in this category, the commercial fleet operators like Ola, Uber, and all comes under this category. Ola, Uber, and all comes under this electric four-wheeler commercial vehicle. And the next one is that electric buses. So these buses is one of the heavy vehicle. So that's comes as a separate category. Then heavy vehicles, lorry and trucks will comes under this category, electric heavy vehicles. So these are all the major classification based on the application. So here the charging depends on the type of vehicles. So that I will explain in the coming slides. About the major components of the electrical vehicle, the electrical vehicle consists of a battery, then battery management system, then charger. So in this in this presentation, I will explain about the chargers, then absolutely electrical motors. So these are all the main components of an electrical vehicle. Battery is the main element which stores the energy and it will deliver the energy during the operation. So battery management system is one of the component. It will monitor the battery during the operation, it including SOC of the battery, then depth of discharge, then SOH, state of health of the battery, then operating voltage, current, and power, and also the temperature. So it including the ambient temperature as well as the uh, cell temperature. So moving further, the charger. So the charger, in a broader perspective, we can classify this charger into two types. For the first one is the AC slow charger, and the second one is the DC fast charger. So in AC slow charger, normally we are using for electric two-wheeler and four-wheeler private vehicles. Private vehicle. So these chargers are normally take multiple hours to charge the vehicle from 0% of the SOC to 100%. So typically it will take 2 to 6 hours time to charge the electric vehicle. So this type of charging method is called as overnight charging. So mostly these type of chargings are used in residential home. Suppose if we are having a electric two-wheeler for our own purpose, so those two-wheeler comes with an electric charger. That charger is called as AC slow charger. So normally it will be in the range of 1.5 kilowatt. So that charger we are connecting to the power supply, and we are charging the particular our two-wheeler. So normally it will take 2 to 6 hours based on the charger capacity, based on the uh, power rating of the battery, and C rating of the battery. So the charging time depends. So these type of chargers are more suitable for the personal vehicle, for the personal applications, mostly charging at home. Okay. Suppose if you are driving the vehicle uh, to the office or within the city, suppose the SOC of the battery, SOC means state of charge. So charge in the battery is reduced to certain value. Let's say 20 percentage. It is reduced to below 20 percentage. So in that time, we have to charge. Whether can anyone confirm whether my voice is audible?
Yes, sir. It's audible. Clear to go, sir.
Yes, sir, it's audible.
Yeah, okay. Uh, suppose if the SOC of the battery is less than 10 percentage, and that SOC is not sufficient to reach our destination. So our destination means going to the office or going back to the home. There we can able to again charge our vehicle. But suppose if we are in between our destination, so that time we have to charge our vehicle in a lesser time duration. So those locations using a slow charger for a longer duration, it's not uh, convenient to the users like us. So in those locations, we need the DC fast charger. So DC fast charger, what it will do? The power rating of the DC fast charger is quite high compared to the AC slow charger. So it will draw the high current from the high power from the grid, and it will charge the vehicle in high power rating. So by using the high power, we can charge the electric vehicle in a lesser time duration. So typically DC fast charger will take 30 minutes to 1 hour duration for charging the vehicle from 0 percentage to 100 percentage. Again, this depends on the battery capacity, battery C rating, and charger capacity. But the DC fast charger can able to charge the electric vehicle in a lesser time duration. So the DC fast chargers are preferred for public charging station, PCS in short form. It is public charging station. uh, DC fast chargers are more preferred because the users like us mostly will come to this public charging station whenever their battery SOC it's not sufficient to allow them to reach their destinations. So DC fast charging is one of the important thing which will help the user to charge their electric vehicle in a lesser time duration. Okay. And one of the important concern moving from conventional IC engine based vehicle to the electric vehicle is a charging duration. Okay, suppose in our conventional vehicle, if we need to refilling the fuel, that is refilling the petrol or diesel, if we are going to the petrol bunk, within 5 minutes we can refill our petrol or diesel tank in our vehicle. But on the same time, refilling the electric vehicle, that is charging the electric vehicle, taking more time. Okay, so in this AC slow charger it will take 2 to 6 hours. In the DC fast charger it will take 30 minutes to 1 hour typically. Okay, so this time leads to the increased waiting time of the user to wait in a charging station. So all the user may not be comfortable or convenient to wait a extended period of 30 minutes to 1 hour in a charging station to charge their vehicle. So that is the one of the important concern which stop uh, transis or it stop uh, moving the user from conventional electric vehicle to the electric vehicle. Okay, so and also there is one concept called ultra DC fast charger. So ultra DC fast charger is one of the type which having the higher power rating of the charger. For an example, DC fast chargers are available from 10 kilowatt to 200 kilowatt rating DC fast chargers. So these ultra DC fast chargers are normally comes in the range of 500 kilowatt and above. So some R&D research and developments are going on for the ultra DC fast charger rating of 1 megawatt and above. So 1 megawatt and above in a fraction of seconds. Let's say within 30 to 40 seconds, an electric vehicle get charged. So Europe countries are leading in this type of ultra DC fast charging. This type of charging is also called as flash charging. I seen in one video that on a public transport bus is charging happened when the passenger are getting down and another set of passenger is boarding the bus. So within that fraction of 30 to 40 seconds, the bus get charged. Okay, so that kind of fast in charging will allow the user to move from the conventional IC engine based vehicle to the electric vehicle. Okay, so the research and developments are going in this ultra DC fast charging. There is an IEEE standard which is under development for the ultra DC fast charging. Okay, so in this photo, can anyone confirm you are seeing a photograph of electric vehicle?
Yes,
Can
sir.
anyone? Yeah, okay, good, fine. In this photo, in the left one, you are seeing about the electric three-wheeler charged by a slow charging. This one is the AC slow charger of 3.3 kilowatt rating. In the right side, an electric cargo charged using DC fast charging. This is the DC fast charger. Its rating is 30 kilowatt. Okay. So when we are using a DC fast charger, uh, this electric three-wheeler is charged from 20 percentage to 100 percentage around 50 minutes. So on the same time, the left one, the similar type of three-wheeler cargo. This vehicle is taking almost 4 to 4.5 hours charging from 20 percentage of the SOC to the 100 percentage of the SOC. Okay, so this is one of the uh, charging station which having both slow charger as well as the fast charger for the charging. Okay, so this is the typical single line diagram of a DC fast charging station. So it will receive the power supply from the electricity grid. So mostly at 11 kV or 22 or 33. In our Tamil Nadu, it is mostly with 11 or 33. And it will having one power and energy meter. So that is power quality meter as well as the energy meter. So as well as our electricity regulation. So we should have a power quality meter at this location. So where the billing is happen, in addition to the existing energy meter for the billing purpose, we have to install the power quality meter as well. Then a distribution transformer. So its power rating, it depends on the charging station capacity. So typically from 500 kVA to 3 MVA, this transformer power capacity will be. Then this will be the medium voltage bus and this will be the low voltage bus. So in this example, you are seeing three charges. So this charging station has three charges, namely 1, 2, and 3. So the electric vehicles are connected in these chargers. Okay, so here there is one. Do you have any questions? If you don't have any question, please turn off your mic. So, and also we are having one more energy meter at this location. So what I mean, in between the charger to the electric vehicle, to calculate how much amount of energy transferred from the charger to the electric vehicle. So that is this meter. Okay, so this energy meter can be a separate meter, or this meter can be inbuilt to the charger. Inbuilt to this charger, also we can able to calculate the energy. So I will show you an example of a energy meter separately, as well as the energy meter inbuilt to the charger. Okay, so this is the typical single line diagram of the EV charging station. Okay, this is the photograph of the electric bus charging. This is the electric bus. You can able to see. This one is the charger connected to the bus. So electric bus. This one is the electric bus, and this one is the coupler. So the arrow mark what you are seeing. So this is called as coupler. So this one will be connected to the electric bus. So this is the electric cable or charging cable. So this cable will come from the charger, right? So this is the another electric bus charging. So this is the bus. Here can able to see a port, right? So this is this port, the zoomed view. So this bus having two ports. Okay, so a connector or charging gun, in other words, this bus having a two ports. So we can able to charge this bus by using two charging guns. So if you are using two charging guns, then it will take lesser time to charge the bus. Or if you are using by only one gun, then it will take little more time. Okay, so in this photo, what you are seeing is a DC fast charger. This fast charger is 120 kilowatt. So the nameplate detail of this charger, fast charger, is shown here. The right side is the nameplate detail of the charger, and left side is the physical charger. Okay, so this charger having two charging guns. So this is the charging gun one. You can able to see this. This is the charging gun one. This side is the charging gun two. Okay, so this charger rating is 120 kilowatt. So each charger is rated for 60 kilowatt. Okay, suppose if I'm connecting this particular charging gun one to the bus, this is the bus. Okay, suppose if I am connecting only one charging gun to this bus, then this bus will be charged one gun rated for 60 kilowatt. So if we are charging the bus using a single gun, then this bus is charging by using the 60 kilowatt charge rating. Suppose if we are connecting the two charging guns like this, so here two port is there. So if we are charging this bus using two charging gun, then we are charging this bus by using a 120 kilowatt. So each gun is rated for 60 kilowatt. So by using a two guns, we are charging this bus by 120 kilowatt. So the time required for the charging is reduced by half of the time by using the two charging guns for the charging. Are you clear as of now? Do you have any questions at this point?
We can proceed, sir. It's clear.
Yeah, okay. Moving further about the charging display. In the left side, what you are seeing is the display of the charger. So for an example, this is the charger I told, right? So this charger having a display like this. The left side one is the display from the charger. In the right side is the display in the bus. Okay. So this is the charger display and right side is the bus display. So here in the charger display, you can able to see, as I told, it's having two charging guns. So when this photo have been taken, that time this charger is charging two different buses by using a single charging gun. So one bus at that time it is 50 percentage SOC and another bus at 99 percentage SOC. Okay. So on the right side, the bus, when this photo have taken, the SOC of the battery in the bus is 26 percentage. Okay. So most of the vehicles, including three-wheeler to heavy electric vehicles, we can able to see how much percentage the charging has been completed in a charger display as well as the vehicle display. Okay. In order to do a authorized charging, most of the charger manufacturers are providing a RFID tag like this. Okay. So this is the RFID based authentication. If if we connect the charging gun to the electric bus, it will not directly charge. After connecting the charging gun to the bus, we have to swipe the RFID card in this place, and after that we have to start the charging process. Okay. Suppose if the charging is completed 100 percentage, then charger will stop automatically. If in between we have to stop, let's say 75 percentage we have to stop. In that case, what we have to do? Again, we have to swipe the card. Then we have to stop the charging process. Then only this charger will stop the charging process. Okay. Unless we have stopped the charging process manually, it will not stop. Okay. And in a emergency condition, there is an automatic push button, emergency push button. If there is some accident or something happen, then we can directly push that emergency button, then the charging process will stop immediately. Okay. So the charger manufacturers are giving a RFID tag or RFID based option like this, and some manufacturers also giving a barcode also. Okay. So the authorized people who are all using this charger, they have to scan the barcode through their mobile app. There is a dedicated app for that. So after scanning, we have to start the charging process through the app. Then it will get charging. The vehicle gets charging. Okay. So this is the a general e-bus charging. Then moving further, this is the photograph of electric four-wheeler using the AC slow charging. So this is the charger. Okay. This is around 7 kilowatt. Okay. So in the left side photo, what you are seeing is the electric four-wheeler. This is the electric four-wheeler. The charging gun is connected. This is the charging gun. So this is the charging cable. So it is a DC cable. So this is the DC cable. It is the DC side, and this will be the AC cable. Okay. So this charger will receive the incoming power supply like this. Okay. It will, the power flow will be like this. So they have connected the energy meter here. So this is the energy meter. This is the single phase charger of 7 kilowatt. So they have connected the charger at the input side. Okay. So this energy meter will account how much amount of energy is transferred from the charger to the vehicle. Okay. So this is the typical AC slow charging for an electric four-wheeler. So this is the battery inside the vehicle. So this is the vehicle, and this is the battery for that particular vehicle. So these are all the positive and negative terminal. Maybe this could be the positive, this could be the negative. Okay. This battery is a liquid cooled battery. So here can able to see there is a, uh, valve pipe, right? So in this one, the liquid will flow and it will cool the battery. Okay. So on the right side, what you are seeing is the voltage and current of the particular charger when it is charging. So the first one, this is the first one is the voltage, and the second one is the current I. Okay. So as everyone know, these electric vehicle chargers are a non-linear device. So it will draw a harmonics. So in simple words, harmonics, that is non-linear voltage and characteristics during their operation. So by seeing that voltage, it should be, it's not a typical sinusoidal. There is a flat. Can able to see there is some flat. So this is due to the harmonics, and also the current can able to see it is oscillating. So in simple words, it contain harmonics. Okay. So this is the charging characteristics, voltage and current characteristics. So moving further, I will touch upon the guideline given by the Ministry of Power for establishing the public charging station. Okay. So the public charging station should have a dedicated transformer. So that is exclusive transformer. In that single line diagram I told, right? There is an dedicated there is a separate transformer. For the public charging station alone, there should be a dedicated transformer based on the supply code of the particular state. We have to go with the exclusive or dedicated transformer. Okay. Then the appropriate civil and cabling works, so including electrical cabling works we have to do. Okay. Then, yeah, adequate entry and exit for the vehicle. Okay. And also adequate space for the charging. So the vehicle needs to come inside the charging station, and it has to it has to charge. Then after that it has to go. So for that, adequate space should be available. Then importantly, fire protection. Okay, so we have seen in many videos there are many fire accident happen for electric vehicle when they are in driving on the when they are in on the road, or sometime on the charging, when at the time of charging. Many videos we seen that fire incident happened. So fire protection equipment we should have at the charging station. Okay, so the charging station which is dedicatedly used for the public charging station. So those charging stations shall have minimum of one chargers. Okay, as per the list. So in their list they have some charger types actually. So based on the types, at least one or more chargers the public
Sir,
charging
excuse me,
station.
sir. Excuse me, sir.
Yeah, yes, madam. Yeah.
Screen is not visible.
It's visible, madam. Visible.
Oh, visible. Okay.
We can proceed, sir.
Yeah, okay. So moving further, the public charging station should have the charger as per the guidelines given by this Ministry of Power in this Annexure 213. Okay, and also some other guidelines are, in order to achieve the online or remote booking, the charging station must tie up with one network service provider. In simple words, internet service provider, so that the charging station can be booked through a remote manner, so that user need not to wait at the charging station. Assume a situation, and there is a charging station near to your place. You are going to that particular charging station for charging. So there is a vehicle is charging when you are reached the charging station. So that vehicle will charging will take another 1 hour to complete. Okay, so even though you have reached the charging station, you have to wait for some time to get the existing vehicle get charged. So in order to avoid those things, uh, an online booking is a preferred option, so that the user can book their convenient time for the charging, right? So Bureau of Energy Efficiency, you might be heard, right? So they are the nodal agency for our country for establishing the charging rations. Okay, and also the technical requirements, the charging station has to comply the CEA technical standards connectivity of the distributed generation resources and measures relating to safety. So in this technical standards for connectivity of the distribution generation, there are some connectivity guidelines are there. So it including the PQM meter should have some connectivity guidelines are there. So in the second one, the measures relating to safety. In this one, the safety aspects of the charging stations are included. Okay, so the charging station has to comply these two standards mandatorily. Okay, so and the the rating, the power rating of the charger should have 100 kilowatt, especially which is used for the e-bus charging. Those shall be 250 kilowatt to 500 kilowatt. And the liquid cooled cables we have to use for the high speed charging. So cooled cable is a special type of cable. There is a dedicated or a special IEC standards are there for the liquid cooled cable, especially for the EV charging applications. Those things, some of the things I covered in my book. You can refer that. So in liquid cooled cable, the electrical conductors are cooled by the liquid. Okay, so what happened? Why liquid cooled cable is required? Okay, so during the charging time, in a lesser time duration, higher amount of power is used to charge electric vehicle. So that time the conductor will get overheated. In order to reduce the heat, liquid cooling is required, right? Okay, so like this, there are some requirements are there for the public charging station. Okay, about the number of public charging station, as per this guideline, at least one charging station is required for 3 cross 3 square kilometer grid area. Okay, this is for a city type of location. For a roads and highways, for every 25-kilometer length on both side of the road, we shall have a public charging station. Okay, so these are all some of the important requirement of this guideline. Okay, about the charger type, the CCS, combined charging station, it is a charging gun type. So the minimum of 50 kilowatt we need. Okay, so that DC voltage range shall be 200 to 750 voltage. So it should have minimum one charging gun for four-wheeler type of applications. Similarly, for Chadamo type, minimum 50 kilowatt, and the voltage is 200 to 500 for one charging gun it should have. So similarly for the slow charger as well. Okay, so this is the typical single line diagram what we seen. So in this single line diagram, I will explain about the surge production. So surge production normally we required to prevent the electrical equipments from the lightning. So from a direct lightning stroke or indirect lightning stroke. Okay, there is an IEEE standard which is dedicatedly written for the surge protection for an EV charging station. Okay, so those standard is that particular standard is given the guideline for the search protection for three locations. The first one is the open location. Second one is the closed location, and third one is the underground location. So in this presentation, I am covering only open location as well as the covered location. Okay, so in this covered open location, all the vehicles and electric vehicle supply equipment, EVSE means electric vehicle supply equipment, so that including a charger and its accessories from connecting to the AC side of the grid to the electric vehicle charger, electric vehicle. Those equipments are called as EVSE, electric vehicle supply equipments. So in open location, all those equipments are in a open premises, so it will get there are higher chances to get affected by a direct lightning stroke. For those type of locations, we have to use category C of surge protective device. SPD means surge protective device. In short form, it is SPD. So for those open locations, we have to go for the category C SPD at the main distribution panel. In this example, this is the main distribution panel. Okay, here we have to use category C, and the EVSE, that is the supply equipment or charger. In those location also we have to use category C. So how many chargers we have? So those many number of such protective device we have to use. So correlating that, so in this example we have three chargers. So for all the three chargers, we have to use one category C SPD here, one more SPD here, one more SPD here, to prevent these equipments from the direct lightning stroke. Okay, so the SPD having some specification. That specification, main specification is called as nominal discharge, ND. This is called as nominal discharge. Okay, so that nominal discharge of the SPD shall be 10 kA kiloampere to 20 kiloampere. Okay, so the reference has been taken from the book. My book I told you in the beginning of this session, and this is for the covered surge protection for the covered location. Okay, so in this example, the covered location, the distribution panel will be in this main building, and this EVSC, or the vehicles are in a open carport. Okay, this is the open carport. So the power supply is coming from this distribution panel. This is this one. Okay, to the electric vehicle charger in a open bay. So those location we have to use the type C category for this distribution board, and category C type of SBD for this EVSC. Even though if it is a covered location, so it means some only this distribution panel will be in this covered location, but EVSE will be in open location. For those location, we have to use 10 to 20 kiloampere of nominal discharge rating of the SPD. Okay, so about in another example, this is also a covered location. So in this location, the distribution panel will be in this main building, and this EVSE, this entire portion will be in this garage. Okay, this garage is a closed garage, so there is no electrical equipments or electrical cable is directly exposed. Okay, so those locations we have to use category C SPD for this distribution panel, and category B SPD for the EVSE. Category B SPD nominal discharge is 3 kiloampere to 10 kiloampere of rating we have to install. Okay, so in this location, in this example, this C became B. It will become B. Okay, so that is the difference. Okay, so do you have any questions as of now? If we don't have any doubt, I will moving further. This is the photograph of the DC fast charger. It is similar to the fast charger what I have shown in the previous slide. Okay, so this is the display I told. The each every charger having the display like this, and this charger having this is the charging cable, and it will have the charging gun. So this is the charging gun. Okay, so this gun will be connected to the EV, electric vehicle. Okay, so this is the RFID tag I told. So RFID card, the authorized user has to swipe the RFID card here and needs to start the charging process. Okay. Okay, and this is the photograph of the battery. In the left side, what you are seeing is a multiple number of smaller rating, which we can able to uh, frame a battery stack. Okay, so this is the individual battery cell. By adding multiple number of cells in series and parallel, we can able to get a higher capacity as well as the desired operating battery voltage. Okay, so in the right side what you are seeing is a battery, single battery with higher capacity. Okay, so all the cells are made in a series parallel combination inside. So it is a simplified package, it is a detailed package. This will be a detailed package. Okay, so moving further, this is the electric three-wheeler. Very recently there is an exhibition happened in Chennai Trade Center. So this electric uh, three-wheeler is displayed there. This is for carrying the goods. Okay, it's having the hydraulic, so easily the loads inside this vehicle can be dropped off. Okay, and this one it's for yeah, vegetable selling or some goods carrying purpose. Okay, so in the roadside you might seen, right? So some peoples are coming in a vehicle and selling the vegetables. Okay, so this they have made for this purpose. This is electric three wheeler for passenger auto. So like how autos are carrying the passenger which is flowing on the road, this auto is for the similar purpose. The battery is this is the battery which is under the driver's seat. Okay. So now we came to the end of the presentation. I will summarize that in this presentation I have explained about the AC slow charging and DC fast charging. I given some example for the AC slow charging and DC fast charging, and also I have shown and explained the electric bus charging and the charger and charging gun, and how to switch on the charging process using the RFID based thing. And also I explained about the barcode based charging, and also I have explained about the Ministry of Power guideline for the public charging station. So it including a dedicated transformer, the number of charger, as well as the internet service provided for the online booking, again liquid cooled cable for the high fast charging, and also I have shown some photograph of the electric three wheeler. Yeah, that's all from my end. If you have any questions, you please ask. And also I will share my LinkedIn profile as well as my YouTube page to you. You can connect with me through that. Okay, there are some other videos also available in that YouTube page, like solar PV system design, it including rooftop solar PV system, then microgrid system. There are some other videos also available in this YouTube page. It could be more useful to you. So that's all from my end. If you have any questions, you can ask. So I have seen one question. What is the budget needed if I have to set up a charging station both highways and urban? So the budget is budget including the land cost as well as the engineering equipments. Uh, so it depends actually. So in a outside the city, you may get the land cost at lesser price, and in within the city, we can get land cost at higher range. So it depends actually. So I don't have in example how much it cost within the city. Some time back I done some calculation, but unfortunately I could not recall. Can have the subsidy for charging station. At this moment, I think there is no subsidy is for the charging station. Okay. Yeah, there are some public-private partnership. It is under the initiative of EESL. So they have some subsidy for establishing the charging station. So they are floating for a tender to establishing the charging station. So they are giving some subsidy for providing some lands actually. So other than that, I don't aware any subsidy for the charging station. Okay. So do you have any other questions? If there is no questions, we can